Hi, 7th grade. I hope you're doing well. Okay, can you believe it? Today is our last day of our online video math lessons. Wow. Well, um, it's been a long journey during remote learning, but thank you for all of your efforts and for being on top of your assignments. I really, really, really appreciate all of your hard work. Okay, so let's learn about complementary events. Let's define them. So let's say we're given an event E. The complement of event E is the event that E does not occur. The complement of event E is written as E with the little dash at the top. Do you see that? Okay, so E with the little dash at the top is read as the complement of E. Let's wrap our heads around again what this means. So normally when we have an event, okay, we learned yesterday and the day before yesterday how to draw a Venn diagram. Okay, so event E is represented as a circle and the sample space is represented with this rectangle. Okay, but the complement of E is the event that E does not occur. So it lies outside of this circle, but within the sample space. That's the complement of E. Okay. So notice that event E and the complement of E are mutually exclusive because they do not overlap. There is no overlap. So event E and the complement of event E are mutually exclusive because there is no overlapping. In addition, it is important to realize that the probability of E plus the probability of the complement of E is equal to 1. It's certain, okay? All right. So now that we have that information, let's look at another example. Let's find the probability of a complementary event. So we have a basket that contains 18 red flower petals and 12 white flower petals. So imagine that in your head. A flower petal is randomly picked from the basket. Let W be the event of picking a flower petal, a white flower petal. We're going to draw a Venn diagram to represent events W and the complement of W. Find the meaning of the event, the complement of W. So it's drawn like this. Okay. Notice here, again, we have the sample space in the rectangle, and it's denoted as an S. And then we have our event W, which is the picking of the white flower petal. And how many white flower petals are there? Well, in the information, it says that there were 12 white flower petals. So we write that information in here, 12. Okay, and then here, the complement of W is the non-white flower petals, which are the red flower petals, and there's 18 of them. So they wrote 18 in the sample space, but outside of the blue circle. So the complement of W is the event of picking a flower petal which is not white. It is the event of picking a red flower petal. Now, part B wants us to find the probability of event W and the probability of the complement of event W. So first, let's find the probability of event W. Now, to do that, we need to find the total number of flower petals. So we gotta add the white flower petals, which is 12, plus the red flower petals, which is 18, and that gets you 30. Once we have that, we realize that the total outcomes is 30 for event W. I'm sorry, not for event W. Just the total outcomes here in the sample space is 30. Now the event W has 12 possible outcomes, right? As we can see from our picture here, and also as we can see from the information here that was given. So the probability of event W is the favorable outcome, the number of favorable outcomes for event W over the total number of equally possible outcomes, which is 30. Okay? And then let's simplify by finding a common factor of 6 and dividing it, and then we get 2/5. Okay? Or you can say this as 2 out of 5. All right. So we found the probability of event W. Now let's find the probability of the complement of event W. Okay? And we'll do it over here on the side. And let me just move this. So there's more than one way to find the probability of event W. Here's the first method. Well, we gotta find the favorable outcomes for the complement of event W, which is 18. Okay, and so they also did the total number of outcomes, equally possibly outcomes, which was 30, minus the outcomes for event W, which is 12, and then you get 18. Okay, or you can just look in the information that was given as well. Okay, now there are 18 non-white petals. So the probability of the complement of event W is 18 over 30. Okay, and then now let's simplify that, and we get 3/5. So that's one method. Now another method is this. Remember this? The probability of an event plus the probability of the complement of the event is equal to 1. Okay, so let's input in what we have. Okay, so let's pretend we didn't know the probability of the complement of event W. Okay, so here we'll have the probability of the complement of event W is equal to, and then from here, we're going to subtract the probability of event W on both sides, right? So then this would cancel out here, okay? And then you get the probability of the complement of event W is equal to 1 minus the probability of the event W. Okay, now let's input in what we know, okay? So we know that the probability of event W is 2/5, because we got that here, right? So then now to find the probability of the complement of event W, we have to do 1 minus 2/5, okay? And okay, for us to do that, okay, recall that 1 minus 2/5, another way to write 1 is to write it as 5/5, okay? Now this makes it easier for us to subtract. 5/5 minus 2/5 is equal to 3/5. Okay, and so that's another way to find the probability of the complement of event W. Okay, let's see. I'm just gonna move this here. Decrease that. All right. So please pause the video and try guided practice number 7 and replay the video when you're ready. Hey, you must be ready. I'm just going to increase my video size because I actually did this on my whiteboard for you. Okay, so it says that you randomly choose a month from the 12 months in a year. So what are the 12 months? Well, I wrote it out like this. Okay, you can see these are the 12 months. And then it says, let A be the event of randomly choosing a month that has the letter A in its name. Okay. So let's see. I'm going to check mark the months that have the letter A in its name. So January, February, March, April, May, August, and that's it. So we have 1, 2, 3, 4, 5, 6. Okay, so we have 6 outcomes for event A. Okay, wait a minute. 1, 2, 3, 4, 5, 6. Oh, we have 6. Oh, I think I did something wrong. Okay, on what I wrote ahead. So sorry. Okay, so we do have 6, right? 1, 2, 3, 4, 5, 6. We have 6 events for event A. Okay, so then now it says draw a Venn diagram to represent events A and the complement of A. Okay, so then 6 here. Okay. So I'm just trying to fix something that I forgot to write. Okay, so far, okay, this is what I have for my outcomes of event A. I have January, February, March, and then I put April last, May, August, okay? So these are 6 months with the letter A in it. And so I wrote it here as A, okay? And then the complement of A are the number of months that do not have the letter A. And then so that should be 6 because there's 12 months in a year. Okay, so I'm gonna write 6 like this. Okay, and my sample space is in a rectangle and I denoted it as an S. Okay. Now it says what outcomes, and the size of my sample space is actually 12, right? Right, because it's the 12 months of the year. Okay. And so event A is the 6 months that have the letter A in it, and the complement of A are the other 6 months that do not have the letter A in the name of the months. That's what this Venn diagram means. Okay. Now part B says, what are the outcomes favorable to the complement of event A? Okay. So the outcomes that are favorable to the complement of event A is listed as this. So they're the 6 months that do not have 1, 2, 3, 4, 5, 6. They're the 6 months that do not have the letter A in it. Okay. And then part C says to find the probability of event A and the probability of the complement of A. So the probability of event A, remember there's, from our Venn diagram, there's 6 months that have the letter A. Okay, so we're going to write that in the numerator, and the total number of months is 12. Okay, and then so we're going to divide it by 6 to simplify, and then this 1/2 is the probability of event A. And then the probability of complement A is, again, there's 1, 2, 3, 4, 5, 6 outcomes, okay, for the complement of A, and then the total number of outcomes is 12. And again, if we divide it by 6 to simplify, okay, we get 1/2 as our probability. All right, so that was number 7. Okay, let's solve a probability involving percents. So look at this example. 25% of the students in the school band play brass instruments. Among brass players, 20% play the trombone. The band director randomly chooses a band member to play a solo. Ooh, okay. So you know that 25% of the band members play brass instruments. Okay. And then of these brass players, so out of the brass players, 20% played the trombone. So that means 20% of 25% of the band members play the trombone. Okay. So just remember that in the back of your head because that's going to come up. So look at question A. It says to draw a Venn diagram to represent the information. So here it is. Okay. So notice here's my sample space with the rectangle. My red circle represents playing a brass instrument with the percentage given, that's 25%. My yellow circle is the percentage that plays the trombone. I don't know it yet, okay? I know it's 20% out of the 25, but I don't know the percent yet, okay? What it is, okay? And then inside this sample space, but outside of the red circle are those who do not play a brass instrument, which is a complement of this, playing a brass instrument. Okay, so B says, what is the probability that a band member who does not play a brass instrument is selected? Okay, so that means you want to know the probability of this, of people who do not play the brass instrument, which is the people outside of the red circle. So, remember this, the probability of those who play the brass instrument plus the probability of the complement of those who play the brass instrument is equal to 1. Now, remember, percentages can be written as a fraction, it can be written as a decimal, and it can also be written as a percent, okay? So 1 is the same thing as saying the percent 100%, okay? And we're going to use percent because we're given percents in this problem. So now we know the probability of those, the percentage of those who play a brass instrument is 25%. It's given here from the information, and also we drew it in the Venn diagram. Okay, so it's 25% plus the probability of those who don't play a brass instrument is equal to 100%. Now I'm going to subtract 25% on both sides of the equation. So 25% will cancel out there. Okay, so then we have probability of those who don't play a brass instrument is 100% minus 25%, okay, which is 75%. So 75% do not play a brass instrument. Okay. So that's our answer. Now let's look at C. What is the probability that a trombone player is selected? Now remember, those who play the trombone is represented by the yellow circle. And also remember, 20% of 25% of the band members play the trombone. Now remember in math, whenever we have the word of, okay, that means we need to do what operation? We have to multiply, okay? So of means to multiply. So we're going to take the percentages and convert them to a decimal. 20% converts to 0.20, 25% converts to 0.25, and of is the same thing as multiplying, which is represented by this dot here. So it's 0.20 times 0.25, and you get 0.05. But again, we want it as a percentage because the main goal of this problem is to use percentages. So we're going to multiply our decimal by 100. Okay, and that means you have to move the decimal place over 2 spots. So 1, 2, and then that'll be 5%. So 5% is the probability that a trombone player will be selected. Okay. All right. Please do guided practice number 8 on your own and pause the video. And when you're ready, let's see what you got. All right. Let's look at 8. So we have 40% of the apples in an orchard are green. The rest of the apples are red. 5% of the red apples are rotten. Okay, so this is our Venn diagram. So our Venn diagram is a sample space of the orchard, of the apple orchard, and the types of apples we have. Okay, and so the blue circle represents the red apples. Okay, The red circle represents the rotten apples within the red apples, okay? And then outside of the blue circle are the green apples, okay? Now they tell us the percentage of the green apples, right? Because it says 40% of the apples in the orchard are green. So I'm gonna write 40%, okay, right here, which is outside of the blue circle, but within my sample space, okay? And then what's next? Well, it says the rest of the apples are red, okay? So then here, if 40% of the apples are green and the rest of the apples are red, then what percentage are red? Okay. Well, remember this, okay? The probability of the event of getting a red apple plus the probability of the event of not getting a red apple is equal to 1. We can also write that as a percent, right? Okay. And then so let's put in what we know. The probability of getting not a red apple is just basically the probability of getting a green apple, right, in this case. Okay. So now I'm going to input in what we know. We know the probability of getting a green apple is 40%. Okay. So now let's subtract 40% on both sides. So 40% cancels out here. And you get probability of getting a red is 60%. Okay. So red apple percentage is 60%. So we're going to put that in there. Okay. All right. Okay. So now we finish completing the Venn diagram. So now let's look at part B. It says, if you pick an apple at random in the orchard, what is the probability the apple you pick is red, that is not rotten? So we have to read these questions carefully. We have to read the information carefully. We can't just assume and just answer, okay? Because just because it was given in the prior example, this will be the exact same question I get, okay? Because in this question it says not rotten, okay? So we're going to figure out what percent are not rotten. We're not figuring out what percent is rotten. We're figuring out what percent is not rotten. So outside of this red circle, within the blue circle, okay? So it says 5% of the red apples are rotten. Okay, so 5% of the red apples are rotten. Okay. So you know then the percentage of apples that are not rotten is 60% minus 5% of the apples that are rotten, which is equal to 55%. Okay, so we're going to put it here. Of all the red apples, 55% are not rotten. Okay? So now we have to find the probability of the apple that we pick is red, that is not rotten. So 55% of 60% is not rotten. And remember, of means to multiply. Okay, so we're going to change the percentages into decimals. So this becomes 0.55 times 0.60. And when we have that, it becomes 0.33. But I want to write it as a percentage, so I'm going to multiply that by 100, and that becomes 33%. So the probability of picking a red apple that is not rotten is 33%. All right, let's solve a probability involving a ratio. So look at this example. Out of 500 students, 156 students study Spanish as a foreign language. Of those studying Spanish, 1 out of 6 students also study French. Okay. So we're going to draw a Venn diagram to show this information, and here it is. Now notice here, okay, the sample space is in the rectangle, and they give us the outcomes in the sample space. There's 500, so we wrote 500 in parentheses. The yellow circle represents those studying Spanish, okay? And there's 156 students studying Spanish. That's given in the information. And then it says, of those who are studying Spanish, there are students who are also studying French, okay? And that is 1 out of 6 students also study French here, of those studying Spanish. Okay? All right, so part B says, what fraction of the students study both Spanish and French? All right, so now it says the 1 out of 6 of the 156 students who study Spanish here also study French. So this is the same as saying 1/6 of these 156 students study French. Now remember, of means to multiply, right? So we're going to do 1/6 of 156 means 1/6 times 156, which is equal to 26 students. So the fraction of those who study both Spanish and French, so there's 26 students out of the total number of students in the sample space, which is 500. And we're going to simplify that by dividing it by 2 and get 13 out of 250. So 13 out of 250 of the students study both Spanish and French. All right, so let's look at part C. If a student is selected at random from the 500 students, what is the probability that a student who studies both Spanish and French is selected? Give your answer as a decimal. So remember, so we know the probability is here, right? Because there's 26 students who study both Spanish and French out of the 500, and we already simplified that fraction here, okay? So we just had to do 13 divided by 250, which is equal to 0.052 as a decimal. All right, could you please do guided practice number 9? This is our last problem. All right. Hi again. So I'm going to just increase the size of my video screen so I can show you what I wrote on my board, okay? All right, so number 9, it says, among 200 jelly beans in a bag, 3 out of every 5 are blue jelly beans. The blue jelly beans consist of light blue ones and dark blue ones in the ratio of 2 to 1. So part A, we want to draw a Venn diagram to represent the information. So I didn't finish drawing my Venn diagram because I wanted to go through the process with you to input in the numbers that are important to my Venn diagram. But so far, from the information, I have this, okay? So my sample size is 200 jelly beans, okay? So that's put in the rectangle, okay? And I have my non-blue jelly beans, and then I have my blue jelly beans here in this blue circle. And then within the blue jelly beans, there are dark blue and light blue jelly beans, but I just represented the dark blue jelly beans in this circle. And then the light blue are outside of this green circle, but within the blue circle. That's the light blue, okay? But this entire blue circle here includes just all blue jelly beans, okay? But I want to input in my numbers for the number of blue jelly beans and the number of dark blue jelly beans. Okay, so let's figure out those numbers now. So I'm still doing A, okay? So it says that 3 out of every 5 are blue jelly beans. So that means 3 out of 5 of the 200 are blue, okay? So remember, of means to multiply. So I'm going to do 3 out of 5 times 200, which is equal to 600 over 5, or 600 divided by 5, which is equal to 120. So my blue jelly beans are 120, and I'm going to write it in my chart like this, okay? So blue is 120. Now within the blue, there's some dark blue and there's some light blue, okay? So let's see how to figure that out, because I'm still not done writing the information in my Venn diagram. So let's look at more of the information. Now it says the blue jelly beans consist of light blue ones and dark blue ones in the ratio of 2 to 1, okay? So it says that we have the ratio of light blue to dark blue is 2 to 1. So there's 2 units of light blue and 1 unit of dark blue. So I drew it here in a bar model. So 2 units of light blue and 1 unit of dark blue. And remember, the total number of blue jelly beans is 120, right? So the total number is 120. So then now I have 3 units of equal size is 120. How much is 1 unit? Well, we need to divide it by 3 divided by 3 gets you 1. We're going to do the same thing on the other side. Okay? 120 divided by 3 gets you 40. Okay, so each of these units are 40. Okay, so now let's see. For light blue, I have 80, and for dark blue, I have 40. You see that? Okay, so now I can write the number of dark blue in my Venn diagram here. Okay, so dark blue is 40, like so. All right, so now part A is done. Okay. Now let's look at part B. Part B says, what fraction are light blue? Okay, so remember, the number of light blue is how many? The number of light blue is 80, right? Okay. So what fraction is light blue? Okay, so to write the fraction, we're going to do the number of light blue over the total number. Okay, so we're going to do 80 over 200, and I'm going to cross out the zeros. Okay, so then I get 8 out of 20, and then I want to simplify it to find the greatest common factor, which is 4. So 8 divided by 4 is 2, and 20 divided by 4 is 5. Okay, so 2/5, or 2 out of 5, okay, is the fraction of my jelly beans that are light blue. Okay. All right, now part C says, if you pick a jelly bean randomly from the bag, what is the probability that a jelly bean that is light blue is selected? Give your answer as a decimal. Well, we already figured out the probability of getting a light blue, okay, which is 80 out of 120. And then, 80 out of 200. And then we simplified it and we got our fraction 2/5. Okay, so I'm going to write 2/5 as my probability of getting a light blue so far, because I already did the work in part B. But now it says I want to get this as a decimal. Okay, so for me it's easy to get it as a decimal if I can have my denominator be a 10 or 100 or 1,000. Okay, so let's see. I'm going to, I can easily make this denominator a 10 if I multiply it by a 2. But whatever I do to the denominator, I have to do to the numerator to get an equivalent fraction. Okay? So this becomes 4/10, and 4/10 is the same thing as saying 0.4. Okay, so this is my decimal. This is my probability of getting a light blue jelly bean, which is 0.4. All right, well, let's celebrate. Woo, it's the last day of online video class. We have one more class tomorrow during our live session, so we can review 10.1 and 10.2, so you can be ready for your assessment on 10.1 and 10.2. All right, I really love you guys a lot. You guys have just been so amazing to teach. I love your vibes, your energies, your personalities, and I had so much fun getting to know you and working with you on your math skills. I am very proud of you, and I hope you're proud of yourselves too for all the work that you've been doing in class, outside of class, and during the remote learning. All right, bye.